Hello, are you familiar with this reaction? This is an alkylation of a terminal alkyne. Okay, look like there are too many steps, but hey, this is really simple. Let me show you. Okay, all right, let's do. We're gonna look at the half of this first. Okay, the second half is the same thing on the other side. Okay, all right, sodiamide. Sodiamide is a strong base. You know what it does? Depronation. A base grab a proton. Just always do like that. Okay. Once you have an alkylate ion, this one is a good nucleophile, a strong nucleophile too. Methyl iodide is an SN2 reaction. That's it. Okay. Resulting in adding a carbon chain onto a terminal alkyne. Okay. Since the second step is an SN2, do you remember the limitation of SN2 reaction? The steric hindrance, if they are this is a methyl carbon, primary carbon works well for SN2. If you have a secondary or tertiary, E2 compete. Okay, so that doesn't really work here. Now it's gonna be a primary carbon only. Okay, all right, let's try this. Do you know what's going on here? Yeah, all right. Start with acetylene, the smallest alkyne. Okay, step one, depronation. Okay, step two, add ethyl bromide. So attack, bam, SN2. Step 3, depronation. Okay. Step 4, this is N stand for normal propyl, not iso, not secondary, tertiary. Okay, this is normal means straight chain. Okay, so straight chain like that, and then SN2. Bam, that's a product. It's just a 2 sets of an alkylation. All right. So look right here. So alkylation of an alkyne allow you to extend a carbon chain, make it longer, basically. Okay, you can add one side, you can add the other side, depends on how many terminal alkynes you have, up to two times total. Okay, now if you have this, do you know that we will need acetylene, a propyl group, and an ethyl group? My point is, can you do retrosynthesis? For example, right here, want to make this guy from acetylene. What do you have to do? You have to alkylate it on both sides. I'm going to show you my retrosynthesis. Okay, so acetylene is the one in the middle. Your retrosynthesis should look like this. Bam! We have acetylene. That's the one you start with. Alkylation on with an N-butyl halide or benzyl halide. Okay. The term benzyl, be careful. This is not phenyl. So this position is called benzylic position. Benzyl group is the benzene plus a carbon. That's a benzyl. Okay, a benzene as a substituent is called phenyl, 6 carbon. This is 7, so be careful the term. All right, starting with acetylene, we'll alkylate on one side first. Okay, you can start with an N-butyl group first or a benzyl group first. Doesn't matter on paper. Okay, all right, do the first alkylation. You're gonna have a butyl group on one side of the alkyne, and then take this guy. Okay, so add sodiamide, depronate it, you can get this, and then attack on the benzylic position. You pick your own leaving group, and that's a target molecule. Okay. All right, we'll practice some more of this later in the actual exam setting, okay, or the actual synthesis question. Let's move to the next video.